Sir, I am an IIT faculty for many years and also an ex-senior professor of a number one IIT Institute of India. I am making videos on different concepts of physics for the benefit of IIT students particularly and in general for any students so that they can be benefited by this. And I have seen in my career that the students are struggling with some concepts, and for that only I want them to be benefited by this video. If so, please like this video and share this video as much as you can, and also please subscribe to this channel because I will be making this type of videos on a regular interval. And also press the bell icon so that you can get the notification of that. And finally, I will request you to make your comments and let me know what are your areas in which you want clarification or in which you want further video to be uploaded. So, let me start today's topic. Today's topic is relative motion. Actually, not exactly relative motion, it is some special cases of relative motion. You know, relative motion you have studied. Relative velocity is VAB equal to VA minus VV, you have heard, because if the velocities of two particles be VA and VV, then the relative velocity becomes VA minus VV. Similarly, if the acceleration of two particles becomes AA and AB, then the relative acceleration also becomes AA minus AB. But there are situations where both the acceleration and velocities are there. In that case, particularly it happens in two-dimensional motion. So in that case, we have to know how to treat this type of problems. I am giving example of two problems. Please listen very carefully. See, the problem is, suppose a train is going with uniform velocity u and a person is sitting in the window of the train. That means he is also moving with uniform velocity u. Now he is dropping a particle from the window. He is just dropping. Then it is supposed to fall downward. Now it is being observed by two persons. One observer A, who is standing on the ground, and another observer B, who is moving with the train, inside the train. So the observation of the two observers will definitely not be same, and they will observe the relative motion in different way. So let us analyze this. Suppose we take the case of A. A is an observer who is at rest on the ground. Now, A has no velocity, so velocity of the observer is 0. And the particle which is being dropped, it has an initial velocity because that is the velocity of the train. So it is, let us say, in the x direction, we call it ux. And it has also a gravitation downwards. After dropping, it will be affected by the gravitation. That means that is downwards. We call it gy. So it has one velocity and one downward acceleration. One velocity horizontally and one downward acceleration. And observer has no velocity. So observer will see whatever is the motion, he will see as it is because his own motion is 0. Now, a motion which has an initial velocity horizontally and there is a vertical downward acceleration, so it is equivalent to a particle thrown horizontally from the top of a tower. Because when we throw something from the top of a tower, it has an horizontal velocity initially and it is affected by g. So it goes down in a parabolic path and it becomes a projectile. So here also the person A will see the particle as a projectile. Now come to the case of observer B. In this case also, the velocity, initial velocity of particle is ux and acceleration of particle is gy. Those two are same, but the observer is now inside the train. So he has also a velocity ux. That means relative velocity of the particle with respect to the observer is 0 because both are moving with ux horizontally. That means if we deduct that, ultimately there will be only one g associated with the particle being dropped downwards. So he will see only that g, and so he will see a vertically downward motion. That means motion will be straight line for him, but for A the motion will be a projectile. So this is the difference. Means at every case you have to take the component of velocity and acceleration of the particle or object and take the component of velocity and acceleration of the observer, then deduct them, and final result will determine which type of motion he will see or the observer will see. So the general rule is that take the velocity of the moving object and acceleration and resolve them in x and y direction. Again take the velocity and acceleration of the observer if there is so, that also you resolve in x and y direction. Now take the relative velocity of the observer and of the object and observer by deducting these two, and relative acceleration also we will find by deducting these two, and to this final acceleration and final relative acceleration and final relative velocity will determine the nature of motion observed by the observer. That means the motion will not be same for each observer. It depends on the velocity of the observer. So this is slightly different when we deal with one-dimensional movement. We simply deduct in a just like a scalar, but in and there also we have not considered acceleration, but when both are considered we will have to take this type of measure. So I hope this is clear to you, and I am giving this type of example because in JEE this type of examples are coming because they are taking all the type of motions while dealing with relative motion. So I hope you have understood. So this was my topic today. I will come to you with some other concept. Thank you.